In this example, we're going to simplify the following complex rational expression. Recall that as we were working through these kinds of questions with numerical examples, our first goal was to create a single fraction in the numerator and then a single fraction in the denominator, and then use the division procedure. In our rational expression, we already have a single fraction in the denominator. H we can think of as h over 1. However, we have two fractions in the numerator. So our first goal is going to be to try to simplify the numerator into one rational expression. Let's begin by trying to find a common denominator for our fractions in the numerator. Our first fraction only has one factor in the denominator, and that's 1 plus x plus h. Our second fraction also only has one factor in the denominator, that's 1 plus x. This suggests that our common denominator is going to be 1 plus x plus h times 1 plus x. Now, since we've multiplied the original denominator of our first fraction by 1 plus x, we also have to multiply that into the numerator. So our new numerator is going to be 1 plus x. Similarly, the new numerator of our second fraction is going to be 1 plus x plus h. I've gone ahead in this step and I've combined the two fractions in the numerator into one single fraction. Notice here that I put brackets around the 1 plus x plus h because I know that this negative 1 has to be distributed to the 1, the x, and the h. So in our next step, let's simplify this numerator and cancel off any terms that we can. So here I've gone ahead and I've distributed that minus sign through the brackets. And what you'll notice is that the 1's and the x's are going to cancel and give us 0. So the only remaining term in the numerator is going to be negative h, and that leaves us with the following complex rational expression. Now that we have a fraction in the numerator, as well as a fraction in the denominator, we can rewrite the fraction bar here using the division symbol. Rewriting the fraction bar here using the division symbol gives us the following. Now we have a division of two fractions. We can use the multiplication by the reciprocal to finish off this question. Notice when we multiply by the reciprocal, our h's are going to cancel and leave us with a negative 1 and a positive 1. And that's going to give us a final answer of negative 1 all over 1 plus x plus h times 1 plus x. Let's do a simplification involving a binomial cubed. So here, in order to expand out this cubed binomial, we can use the binomial theorem. So x plus h cubed is going to give us x cubed plus 3x squared h plus 3x h squared plus h cubed. And let's tack on that negative x cubed, and all of this is going to be over our denominator of h. Notice that our positive x cubed will cancel with our negative x cubed and give us 0. And so we're left over with 3x squared h plus 3x h squared plus h cubed. And it looks like all of the terms in the numerator have an h, so let's factor out that common factor of h, and that's going to give us 3x squared plus 3xh plus h squared. And now as long as h is not 0, we can cancel off this common factor, and we'll be left with 3x squared plus 3xh plus h squared.